Well, actually, we were talking about that this morning. Um, well, those guys actually like have you if you watch like The Rock and John Cena or even Hulk Hogan, these guys actually were like legitimately pretty good actors. So like it takes a skill. So yes, it's choreographed, but it's still physical. It's not like these guys are out there just dancing around, barely touching each other. I mean, it's still a dangerous thing. Take somebody out with his cast. All right. So, oh, did I start the recording? Yes. All right. So our homework was to go through and mess with our let's see what I gave you. Okay, so mess with our Pokemon thing. So I gave you a URL here that I think we talked last time. If I open up the slides, we are talking about how our modern APIs actually work. So we talked about several things. We talked about the idea of generics. Those are the angle bracket things that look scary, but all they do is say, hey, we'll go ahead and typecast stuff for you. So you don't have to do the extra work. We talked about hashing algorithms, one-way ciphers. So a infinite size input, any size input turns into a finite size output. Therefore, you will have the possibility of collisions. So most of these algorithms have collision avoidance aspects to them. MD5 is message digest 5 is what MD5 stands for. Um, so that's often used to like validate that the 7 GB file you just downloaded was accurately downloaded because the chance of you running MD5 on this 7 GB file and getting a matching hash value because it was corrupt in just the perfect way that gave you the identical hash value is incredibly unlikely. All right, so that's how that guy is commonly used. And the reason we talked about that is we saw that when we investigated a little bit last class, that the underlying data structure that actually was returned by our JSON parser is what was called a linked hash map, I think is what it was called, which was a map. So we looked last time at the idea of a map interface, and here's the things that all maps have to give us. And from our perspective, that's good enough. Like, okay, I want to have name value pairs. Give me the value associated with his name. I'm happy as a clam, right? Um, we don't really care how it's being accomplished under the hood. But what was interesting about the fact that we saw that it was a linked hash map, that kind of gave us some information that, oh, this guy truly does work like the dictionaries in other languages, which do not guarantee order. They are storing the name value pairs. The names are hashes. So we can't necessarily guarantee the order that they're going to be in that collection. So you don't loop through the collection by saying, give me the thing at bucket 0, give me the thing at bucket 1, give me the thing at bucket 2. You go through and say, give me the thing at bucket name, wherever that is inside your collection. I want his value, the value associated with name. All right. We talked about HTTP. We talked about the word protocol. What does the word protocol really mean? What should you think about when you hear the word protocol, um, based on what we talked about last time? Okay, no, make something new up that's better. See, human misery, right, right there.
It's a set of.
A protocol?
Well, I mean,
No, yeah, hypertext transport protocol. Protocol means what? Language. So this is the language that these things are talking to each other, just like we're speaking English. HTTP is the language that web browsers speak to web servers. It's also the language that we now have our programs speaking to API servers because they are using that same language. Why are they using that same language? Is because the folks who started saying, "Hey, I have a computer program that I want to talk to a data source somewhere on the internet. I need a way of doing this." In the early days, every single person who put their data source out there on the internet had their own little proprietary format. I remember writing these in the very early days of the internet. Like I told you about the thing I wrote the other day with Boodlebox. That's like something I always mess with. You get a new technology, you say, okay, well, how can I automate some aspect of this or whatever? So I remember kind of like when the internet was first a thing, and I had some a database of something that I wanted to share with my programs, and I wanted it to be a convenient way of having 3 or 4 different programs all talking to the same kind of data. You create your own little program that reads in from the database and then makes it available by request. But I had to invent my own little language for when something can. I have my own little socket server running here, which we'll talk about here soon enough, because we're going to be talking about network programming, socket servers. And that guy would listen for an incoming connection. He would then spin off a thread, deal with that connection, and he would have to give him the data. Well, he would have to know how to ask for the data. Well, I wasn't using HTTP in the early days. I was using the Mike Lippman invented sentence protocol or whatever, where it would say, give me this data source, and I would go get it, and nobody else really could use my data source because A, I didn't tell them where they could find it, and B, I didn't tell them how they can talk to it. Where now we have a standardized mechanism for talking to basically all APIs that exist. Doesn't matter which API it is. If you know how to talk to our Pokemon API here, you can talk to ChatGPT's API. You can talk to insert API here, whatever the modern API is. And at the end of the day, what is important to us about HTTP is HTTP really has 4 main functions. Later versions of HTTP added some additional stuff, but really 4 covers us here. So we have 4 different functions that HTTP knows how to do. It knows how to handle gets, posts, puts, and deletes. Now, those are the 4 functions that have been inside of HTTP since day one. All right. And some API people looked at that and said, you know what? Here are the things that we might want to do with an API. We might want to get existing information. We might want to put in new information. We might want to update existing information, which is a put. We might want to get rid of existing information, a delete. So we're either requesting stuff, getting it, putting new stuff, posting it, updating old stuff, putting it, getting rid of old stuff, deleting it. Every single thing that we might want to do in an API can be done with one of those 4 things. So we actually let the HTTP methods dictate the kind of ninja move this call makes. All right. So if somebody hits you with a post, by best practices, your API likely should be taking in new information and updating the database. Nobody says you have to. You could have a post that gives information. You would just be kind of pushing against the grain, because somewhere you're going to have your documentation for your API, and you're going to say, hey, here's all my endpoints for my API. And like here, let's just let's do Open AI API documentation endpoints. This will be a little bit more let me see if I can just get us to a thing that just shows me some endpoints. Well, let's take OpenAI out of it. So I don't know if I search too much. Is this guy going to give me some examples? Can't find a good API. Let me just get to it here. Okay. Here's like an example. So we're looking at some documentation here for the OpenAI. This is on their developer protocols. Usually websites for this would be like developer.openai.com. I didn't check to see if that is the case here, but yep, developer.openai. So when somebody talks about endpoints, what they're talking about is things that look like this: slash responses, then you give it a JSON object with the response ID. Slash responses, you give it the JSON object of the response ID. So these are all endpoints. But notice before it, it is showing us the type of method that you need to um, call this with so that it knows the way it should be communicating with you. So in this case, a post, this creates a model response. So we are creating something new. Get a model response. So responses slash response ID, whatever, you must have this number somewhere. That's a get. Now remember, gets, that is what we by default see in the URL of our browsers. So that's why we were able to put in from our code here. That's why we were able to take this string right here, which if we were looking at the documentation for this, this guy would be listed as a get endpoint. So what's the endpoint? The endpoint is, well, so depending on where it is. So pokeapi.co/API/v2. I'm guessing that this is the API and the endpoint is here. This is the slash Pokemon endpoint, and it happens to be a GET request. Now, if I hadn't told you that this guy was a GET request, but I said that this string works, is there anything about this string that tells you this guy is likely a GET request? So this is kind of falls into the same categories when I ask you when we see Java code or see any sort of programming languages, is this a class method or an instance method? What if I'm telling you this works and we saw it work last class, right? Go ahead. Nope, because since we're using HTTP, 100% of our calls will start with HTTP or HTTPS, either secure or unencrypted, because they're all HTTP. Just some of them will be gets, some of them will be puts, posts, or deletes. I'm telling you, this one is a get. You are right, 100% of things that we see at the top of the browser are gets. If it works in the browser this way, it is a get, but it's not because it has the HTTP in front of it. The HTTP says, I'm speaking hypertext transport protocol. So really what we're looking at here is go ahead. The question mark's involved here. So really we're saying, how do we get information into this guy? So GET requests typically use when we have a collection of name value pairs, which is what we have right here. There's one name value pair, limit equals 100,000. And here's a second name value pair, offset equals 0. So we're able to pass that as with a GET request using the question mark as the starting point that says, all my name value pairs come after this. And then we have the little ampersands between each name value pair. All right. So this is how web browsers represent their GET requests up there. And we can talk to GET requests by building them this way. But if we're working with posts or something like that, we have to format it in JSON in another format for it for us to work with. But if we see a line like this, it starts with HTTP something, and you start seeing question marks and ampersands in it, it's either a non-functioning thing or it's a GET request, because that's what GET requests have in them. A post would not look this way. If you want to create a post on your web page, you would have to build a web form, set the method for the web form to be post. Let's see, HTML form. Let's just say form tag. Let's see who comes up. Here's W3 Schools. So we see up here when we create a HTML form, how many of you have done HTML and have created forms? A lot of us, right? At some point, following a tutorial, whatever. How many of you on this very top line where it says form action equals and then method equals, how many of you just typed whatever you wanted in here based on the tutorial you were following? Realistically, right? This method equals can be get, post, put, or delete. That's what it's talking about. It's saying which method of the HTTP protocol should this form play by? What rule should it play by? Now, the reality is behind the scenes, the only one that plays differently in terms of how you interact with it is the get, because it lets you put everything in the string. You don't necessarily have to, but it lets you. Whereas all the other ones require you to kind of package up the information as part of the request header for this website sending this information, and then it gets unpacked someplace else. All right. So the point is you've seen this stuff before, but probably just glanced past it because, oh, I put get there. Because 90, well, anymore, probably 30% of web forms use get. 70% of them use post. Why do you think that the more common web forms use post instead of get? You well, when I'm saying on the web, so this predates the idea of how we might use HTTP in other ways to get data. So API usage for us, that's us taking something that already exists and repurposing it for what we want to do. But when we stay in the web world here and you create a web form, you will basically never create a web form that is a put. You will never create a web form that is a delete. You could, but that's not something that you would ever see in web development. You would see gets and you would see posts. Now, why might you choose a post instead of a get if you're making web pages?
Aren't you trying to put the website contents onto web? That's making sense, but you're not taking time to wrap the quick.
Let me do something real quick, and I think it will show you the answer. So I'll have that. And what we're going to do here is we're going to say CC equals 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So that's kind of a credit card number. Would you want to have your credit card number up on the URL where somebody standing behind you could just see it? What about username and password? Probably not. Okay, so in the relative early days, you would use a post instead of a get because you didn't want your sensitive stuff to be in the URL where anybody who's near your shoulder can see it. But that doesn't mean that it's protected in any special way. It's still inside of the HTTP header that would get sent over the internet. So anybody who is doing, if you're sitting in a coffee shop and this would be something, I don't know if Dr. Wall has you do this in the cybersecurity class, but it's an interesting experiment to do sometime. Don't do anything malicious with it. But if you take some of the cybersecurity tools, you sit in a coffee shop and you just do packet sniffing, you will be surprised at the amount of information you can collect about the things that are going on in that coffee shop in terms of, what sites they're visiting and things like that, that you if you knew people could see that stuff of what you're doing, it might make you uncomfortable depending on the kind of work you do. That's why companies have things like VPNs, or every single website and its brother uses HTTPS. So all that stuff is encrypted. So as humans, we don't have to do anything different. The security protocol on HTTP just says, hey, anything you send or receive will encrypt it for you. You can just you can decrypt it on the ends to get what you need. All right, so that's the get versus put thing for the early uses of it. So we've just expanded that into the world of using APIs by saying, hey, why invent a new language when HTTP is already there, it already works, and it does everything we need it to do. I kind of need to do 4 different types of things with APIs. I'm either serving data, I'm creating new data, I'm updating existing data, or I'm getting rid of existing data. Those are the 4 things we do with our data. Might as well use it. All right, so what I left you with last time was this a starting point for Pokemon, where I gave you this URL. We saw this URL work. So if I just paste that guy in there as is, we get a wall of JSON. So we see this work. It is a GET request. I didn't really look at the documentation for this guy to see what other endpoints it has. This is good enough for us here. But what this does is says, give me all the Pokemon with 100, with a limit, a maximum number of 100,000 of them, and start at the beginning. Don't offset at all. And the reason this offset might be in there, we might run into it here, is maybe it only shows us 200 at a time and then gives us the next offset so that when we call this URL again, we say offset at 200. Pick up where we left off. Now it's at 400. Pick up where we left off to keep reading in the screens of stuff. That might not be the way it works here. I'm guessing there aren't 100,000 Pokemon. No. Okay, so a lot less than that. So chances are this is giving us all of them, but we'll see here pretty quick. But that's something to keep in mind for other APIs, is sometimes if there's tons and tons and tons of data, they will give it to you in smaller chunks at a time for you to be able to work with. All right, so rather than going fishing through the website, let's just explore it through our code. So we are creating the URL around this string. A URL is Universal Resource Locator. It's how we find stuff on the web. All right, so we're going to build that guy around it. Then we're going to build a scanner using the stream associated with our URL. So this line right here, that opens up a connection over the internet. So 2 lines of code here say, I'm going to go to a web page, open up the stream to that web page. And now all of a sudden our program's talking to the internet. 2 lines. All right, so we're going to build the scanner around this line. Why? Because scanners let us read stuff in 1 string at a time. That's a nice, convenient way for us to get our stuff. All right, then what are we going to do? Well, we don't know how many times we're going to have to read from this endpoint to get all the stuff. It's possible it gives us to it as a wall of strings. It's possible it streams it to us and we pick it up at a kilobyte at a time or something like that. Different things give you the data at kind of different cadences. So we're saying, I'm going to use a scanner here, and I'm just going to keep reading from this guy as long as there's something to read. And what am I doing? I'm starting off with a string called response that has nothing in it, and I'm just building that dude up. Everything I read from there, I'm just adding to my string. So when all is said and done, when I get to this line right here, I should have my string. All right, so let's go ahead and run this. Make sure we have a wall of JSON-y stuff. All right, so that looks like a wall of JSON-y stuff. All right, so now what we want to do, so before I go, any questions about this? Go ahead.
It's not on this. Going to is or excuse me, what's the difference between the array list that we had in Java code versus just like a regular standard array? Like array list string or array list?
An array list is an array list.
It's like that. Does that ever change anything?
Well, yeah. So you said it shows map in the square brackets for our array list when I go up here. So that's when we were talking about generics last time. So let me bring this stuff in and we'll talk about it. So I'm going to go ahead and I'm going to use this guy. So right here, I know I have my JSON string, which is just like what I had above, right? So I'm going to go ahead and I'm going to use my JSON parser. And instead of passing it data, I'm going to pass it the string that has my stuff in it, right? And that guy is going to be, um, uh, well, when I say JSON parser, then I say dot parse. This is going to give me the parsed version of all that JSON. Now we know at the top level of any JSON document, we have a JSON object, right? That guy's value could be an array, but always at the top level, we have at least one name value pair, right? So it's going to be a map. So let's just look at this real quick and remind ourselves what we saw last time. So I'll do a system.out.println, and I'm going to say obj.get, is it just get class? You would think by now I've typed it enough times I remember it. Because we're going to say generic object, tell me who you really are. Because he was stored in there as a generic object. Tell me who you really are. So I'll run this. It's going to sit there. It's parsing it. It's parsing it. So this guy says, I am a linked hash map. He is a map. All right. So now if I say object obj2, and this guy is going to be, I'll just go ahead and say, this is the map version, and pay attention to this because this is the thing that using generics lets us avoid. I'm casting my obj to a map first so I can use it as a map. Because right now, Java thinks it's a object, generic object. So he's only going to let me make method calls on this guy that belong to the object class. Even though we've done a little investigating and we realize this guy's a little bit more than meets the eye, right? He's actually a map, which is much more than an object is. But because he's currently an object, I'm going to work with him as if he's an object and I'm going to convert him to a map myself. I've now typecasted that guy object to be a map. Now you can't just do this with any old thing. You can't take an int and say, ha, you're a map. That's not going to work because as soon as it starts typecasting, it's going to realize that, oh, this is not a map and it's going to have problems. But in this case, it's like, oh, it is actually a map. So I'll go ahead and in this line alone, because we haven't changed anything with this, in this line alone, from this point forward, you can treat it as if it's a map. And I believe we had what's the top level? Let's see, I commented out here. Give me a moment. Let me just do this. I just want to find out what that top level variable is called. Actually, you know what's going to be, well, I can't actually, let's do this. Response dot substring 20. That should give me the first 20 characters of it. Whoop, whoop. That's actually weird. It didn't give me the first 20. Response is my thing, substring. Yeah, that's better. Oh, we actually have several name value pairs here. We have count, then we have next. So let's give ourselves a little bit more than, let's give ourselves 200 characters. All right, I'm just going to ask for results. So here's an example of some JSON where the top level actually has multiple name value pairs. So we have a count equals 1350. So there's 1350 total Pokemon in their database. Next, whatever that is null. Probably it's that thing where it's only going to show you so many per screen. Um, Previous also is null, shows you the last group you went through. But results, this is really what we want. This is our array list. So let's go ahead and get the results variable from this so we can look at the kind of animal that returns. All right. So I'll go in here. I'm going to say we are going to use object 2. We are going to get results from that. And we'll do a system.out.println obj2.getClass. And we expect this guy to be a array list because that's what we see. Results is equal to something that looks like an array. So we'll go ahead and let me make sure I have my other println out. Okay, so we have those two guys. Okay. So we have our map is the first one. And the second one is our array list. All right. Now we know when we look inside of this, if we say array list, so let's say I do, well, here. So I'm going to say object obj3 is equal to the array list version of obj2 dot get bucket 0. So that guy is the first element in the array list that is the value associated with results in our JSON. So if I say get this guy's, well, actually, I'll just throw him in that class. So I actually didn't need these extra set of parentheses. So I'm storing the thing that is at bucket 0 in that array list. I'm storing that in a generic object. Now I'm going to go ahead and we saw it up. Oh, it's already gone. We saw it as an array list. We know it should be filled up with a whole bunch of Pokemon, right? Am I saying that right? Pokemon? Pokemon? It's not Pokemans. It's Pokemons. All right. So that guy is a JSON object. So this should be a map, right? So we're kind of predicting what we're going to run into. Where results has a value of an array list, which contains a whole bunch of maps, where there's a map for each Pokemon. So we'll go ahead and do a system dot out dot println obj3 dot get class. And we expect this guy to be a map because that's what's at bucket 0 of our array. See this here? It's a map. So our top level thing is a map. That's how it's always going to be for every single JSON string. Top level is a JSON object, which is going to be at least one name value pair. In this case, I think we had 3, unless there was something that came after the array, but let's say 3. And we could actually ask that top level object what his values are. But so if I do that, let's look quickly at Java map. And if I remember correctly, this is an interface, right? That defines all these other things. And remember this syntax right here, the KV thing? This is key, that is value. And Carnival last time said that he's scared of this. I just want to say that it doesn't take a whole lot. So, I mean, but when you look at that, the syntax is kind of freaky, right? When you're not comfortable with looking at these things, this is kind of freaky, but this says that a map interface can be any key value pair. We've developed it to be generic, and we've given you a tool, generics, that allows you to specify the exact kind of data your keys are and the kind of data your values are, so that you can take this kind of blueprint and turn it into your own thing that allows you to not have to do stuff like that. Cast something that we know is an array list, to cast it from an object to an array list. Why doesn't it just come out as an array list? That's what we can make it do by using generics. And we'll get to that here in a second. All right, but what I was looking at here in map is we want to go see what are maps capable of doing. Since we're treating all this as maps, even though we saw it's a linked hash map, it's a specialty map. All right, we're going to look at what can all maps do, because chances are we're looking at name value pairs. A map is a map at that level. So this guy's going to have gets and stuff. And I'm going to look for, how do we get the list of all the keys? Let's see. So this gives us get something given its key. Here's key set, returns a set view of the keys contained in this map. I bet you set already has a toString. So we probably can just say key set and print that, and it'll show us the keys that are in there. That would be my guess. Because this guy comes out as a set of whatever type the keys are. All right, so let me, go back to here. Hold on, I'm lost. What was I doing? Oh, keys. So I'm going to go ahead and print out obj3, which is an object. I'm going to print out his key set. Now, really, this guy needs to be treated as a map, right? So we're going to say you are a map. So I got to do all this typecasting crap. You see how that might become kind of a headache after a little bit? Not a big deal for our little experiment here, as we're kind of, looking through our JSON and saying, well, what do we actually have here? And why did Java do it this way? It did it this way so we didn't have to write our own custom versions of map for every little different data set. It gave us like a transformer, right? We have a transformer here, and as long as we give it the right kind of starting point, it could just behave the way we want it to behave from that point forward. And we'll change it to that here shortly. But hopefully what this does, and actually we don't want OBJ3, we want OBJ. We want to know, and here, whatever. We want to know what are all the keys available to us at the OBJ level, that top level. So we're going to make that guy into a map, which we know he actually is. And we're going to ask that map, give me your key set. Show me all the name value pairs you keep track of. Basically, show me all your names. The names are the keys. All right. And that'll come out as this set thing. And we're rolling the dice at the moment, thinking that, okay, the people who wrote set, which is probably also an interface, rewrote the toString method to not show memory addresses, but instead show string key looking things that we can read. Let's see if our prediction is right. Okay, so we see we only had, what's funny is I know we saw every single one of these, and I counted this to 3. That's the kind of competence you're getting in front of your classrooms here. It's like, we can't count. We've gone downhill. All right. So we see here's our list of keys that are in there. So this might be helpful for us because, first of all, now as programmers, we've done a couple of lines here, but we're able to now explore the nature of that wall of JSON that, sure, we could have copied that into a into a text file or something like that and done some search and whatever and looked for, where's the beginning of it so we can kind of see the beginning and see, oh, what things are here is the name value pairs. We could have figured it out by the text, but why not ask the code? Sure, I mean, this is only what, 6 lines of stuff that's allowing us to see that, oh, we have a map that contains an array list that we happen to know is associated with this key, but we also happen to know that we have some other keys in here. And the chances are count that type of key is probably an int, his value. So if we go up here and we change this guy, instead of results, we say he's a count, and I'm going to go ahead and get obj.get class and print that out. Let's see what he looks like. He's a long. So they do it as a long instead of an int. Interesting enough. Does that kind of jive with count equals whatever it was, 1350? Seems to make sense. What was our other guy? What was the second one? Oh, we had some null values, right? Next. Okay, thank you. So let's throw next in here. It's coming out as null, but I'm guessing that is a type right now. Let's see if it's real null or string null. Ah, just null pointer exception. Okay. So it literally is nothingness. Which now what does that tell us? It tells us that our JSON parser, if it reads in something that is nothingness, it will behave as normal Java nothingness. Therefore, we would have to probably check to make sure it's not nothing before we start doing math on these things or using those values. Okay, questions on any of this now that we've kind of explored our data? From our perspective, we're really dealing with 2 different kinds of animals here. We're dealing with maps. Well, we're dealing with at least 3 animals in this case. We're dealing with maps, we're dealing with longs that we're not going to look at very much, but we're also dealing with array lists. All right, so collection type, and well, both are collection types, but our JSON objects are what would have been a dictionary in another language is a map in this language. All right, so now let's go ahead and start getting these things. So now we know that object here. So here, let's call this guy top level. We know this guy is actually going to be a map. All right. And this JSON parser is going to give us the value of this dude. And what we're going to do is at the top level, we'll just go and turn that into a map. So now from this point forward, top level is a map. All right, we only had to cast it once. Now from this point forward, when we talk about top level, he's a map. All right, so now we know, I'll go ahead and get rid of this guy. We know that this guy is going to be an array list of maps. We'll call this the results. And this guy will be top level dot get. Was it result? Was that it? Okay. So we're going to create a variable, name the results. He will be of type array list containing maps because we've already pieced it apart to see that's what's in there. All right. So that'll give us our array list of maps that hold each of our Pokemons. All right. All right. So now we can actually do a quick little for each loop. But actually what I'm going to do is I'm going to do this. I'm going to say map temp is equal to the results at bucket 0. And the results is an array list of map. So we don't have to typecast it, right? It's already coming out as a map. So temp will be that map. And what we can do is say temp.get Does it get keys like that? From that map? I think that's what it was. Oh, I have OBJ stuff in here still. One is actually called, oh, I actually don't even need that anymore. So we have our results. We have that. Okay. Array list. Oh, this guy here, results like that. Oh, thank you. In my defense, she said yes. Yeah, wrong as usual.
It's still wrong.
Well, it's wrong for a different reason, probably. All right. Object cannot be converted to array list. So this guy will come out of here. Oh, it's because I didn't cast this guy to an array list of map. Hey, you still said it was wrong. Or you still said it was right. Unless results isn't the right thing. Array required, the results. Oh, sorry. Array lists in this language don't behave like Python. So this is get 0 instead of the brackets. And cannot find the symbol. We have map temp that comes out. So is get keys not the right key set? Key set. See, you probably would have said yes to that too, wouldn't you? Oh, it's perfectly fine. Just trust us. Teach you some new skills. I try to test you on it. We get nothing. Oh, that's it. So every single well, let's see. The result at bucket 0, that's a name and a URL. That's it. Every Pokemon is a name and a URL in this data set. Okay. All right. So then we know that we have the name. So then what we can do is we can mess with this. We can say for map n or map m in the results. This is a for each loop. We can say string name is equal to the string version of m dot get name. And then we'll do a system dot out dot println name. So we'll go through every element of the results. For each one of those, it's going to be a map. So each time through, M will be the map we're looking at. We will get from that map the value associated with name, which I am assuming is going to be a string. It'll probably come out as an object. Why? Because those maps, the way they had to be designed is to be the key value pairs were string object. Now, why does this map have string as our keys? That part makes sense, right? Our keys are going to be like name, results. Those are all strings. But why is the value object instead of like string or long or something like that? Why is my value type for all my maps here a generic object instead of something more specific? No, it has nothing to do with hash maps. You know, and this isn't even a trick. What are the kinds of values that a JSON object, which a map represents, right? A map is effectively our way of programmatically saying JSON object, right? What are the kinds of values that can be associated with keys in a JSON object or a map? Strings could be one of them. We could have keys that are strings. What else have we seen? We saw integers through a long. We saw it defined as a long. What else? Array lists. So at least 3 different things we've seen, right? So if you're going to create one generic type to cover at least these 3 things, right? You kind of need to go to object because we have a whole bunch of different crap that can live as values associated with our keys. Does that make sense? That's why they chose object. And that's an important thing for us to consider is as computer scientists, we want to understand why they made that decision because the reason they made that decision is going to help us make decisions in the future. I need to hold a bunch of different kinds of things. So I can't just say it's a string because that means I can only hold strings. I can't just say it's a array list of longs because I can hold things other than longs. I have to say it's an array list of string object pairs. Okay, because our types can be all sorts of stuff. So m.getName will come out as a generic object, even though we know that the name, actually, I'm banking that all the Pokemon have names that are strings because we're about to find out how bad does this Pokemon world go. So we're going to get the name of each Pokemon. We'll store it in a little variable. We didn't need to do that. And then we'll print it out. We're going to do this for all of our guys here. And I'm actually going to do something real quick. I just want to know, does it give us all of them at once or does it give us a subset of all the Pokemon? So I'm just going to count as I'm going through there. Actually, I could have just printed out the results.size too. Well, we'll do both. So we'll do a system.out.println count after I've done all the incrementing. And then we'll do a system.out.println the results dot size. So an array list has a size method which works similarly to the length field of an array or the length method of a string. So for array lists, it's called size instead of length. All right, so these two numbers should match. I'm hoping it shows us all the, actually, it doesn't necessarily matter, but I'm going to go through here. I'm going to print out the name of each Pokemon. I'll count the number I run into. I'll then print out that number. I'll also print out how big the array list is, which should be the same value. All right, yep, we get all 1350, which is good. And those are a bunch of Pokemon names. Is that right? Oh, there's mega versions. Is that like a, what is this, when they evolve? Ooh, that sounds dangerous. That's some serious stuff going on here. All right. So make sense? Any questions about what we've done here? All right. So now, having said that, what were we supposed to do with this data?
You said that we're supposed to have it iterate through so that we get the option we want, whether get it by ID or get it by the name.
Okay, so either get the Pokemon by ID or get it by the name. Oh, this actually becomes more interesting. So if we now turn this into the URL, which was our other thing, we're going to get a bunch of URLs, right? So now let's go ahead and run this. So we're going to get a whole bunch of website URLs, presumably. All right. Oh, and this gives us a bunch of IDs here at the end, right? And we were supposed to give a menu of, do we get this by name or ID? And what are we supposed to be getting? What did I tell you to get? Oh, okay. So we get name and ID regardless of what we ask for. But if we ask for the name, we will come back with just the ID of that name.
Yeah.
Okay, got it. So I'm going to do a little experiment here. I'm going to grab one of these URLs. So we actually see the format of this URL. We see the endpoint, right? So this is a /Pokemon/ID endpoint. So I'm just going to paste that into a new page. Let's see what we get from this dude. Oh my gosh, we get a bunch of crap. Look at that. Woo. Okay, so let's explore. So what we're going to do, oh man, this is going to be fun. Wait, I'm lost. What site am I on? Oh, here, I want to go here. All right. So we know we can get these URLs. So we have this URL. Did I already name something that? I called it URL string. Okay. Oh, wait. I called that URL. So we'll call this the Poke URL. All right. So this is our Poke URL. We already know it's a real place. We don't need to do this count stuff anymore. We know we're getting all this junk. Okay. So now what I want to do is for each of those URLs, let's go ahead and let's get the let's use our JSON parser to parse for us another object that has all the stuff with that guy. So let's see kind of what we're dealing with there. All right, so I'm going to go ahead and I'm going to say we're going to turn this into our URL just like we did up here. So I'm going to say URL temp URL is equal to new URL with pokey URL. All right. So now I have that URL, just like we did up here. Because what is at this URL? This URL holds more JSON. And if I have JSON, what do I do with JSON? I parse it, right? I have a JSON parser. So I'm going to parse this additional JSON that I found as I was walking through my parsed version of the original stuff. All right, so I'm going to take, wait, I'm lost. Okay, I'm going to take this guy. I'm going to build my next scanner. Scanner temp scanner is equal to a new scanner with temp URL dot, what was it, OpenStream? Oh, I didn't. I was testing you. All right, you passed. That's fine. I mean, I wouldn't say a star for the day quite yet because you're starting at a way down there. It's bad. All right, so we have temp scanner, new scanner, temp URL dot OpenStream. Oh, actually, hold on. I can test it up here, right? I can look. Yeah, dot OpenStream, capital S. Yep. All right. So now that's going to allow me to go through my scanner and read stuff in. All right. So I have I can basically use something very similar to this. While scanner has next line, blah, blah, blah. So we'll go ahead and say string temp JSON starts off as the empty string. I'm not sure we're confident yet that we read it all in as one string or not. So I'm just going to do the same thing we did before. So while temp scanner dot, what is it? Has more, has next line. So as long as there's something else to read from our temp scanner, which was built using the using the stream associated with our URL, which is the URL of this particular Pokemon that we're looking at in this particular iteration through our list of name URLs, dictionaries, maps. All right. So we'll go ahead and say temp JSON plus equals temp scanner dot next line. Read all that in. So when all is said and done, we have our JSON string. So now from our JSON string, we want to go ahead and create a map. Temp map is equal to, we are going to have something that is going to be a map that is going to come out of JSON parser. Actually, I think it's new JSON parser, right? New JSON parser built using our JSON, which is temp JSON. And then we're going to tell that guy to go ahead and parse himself. All right. So that will be our temp map, right? And then what we'll go ahead and do for each of these right now is we'll say, println temp map dot keyset. Oh my gosh, just killing me. All right. Is that what it was, keyset?
This time.
All right. So as I'm going through my original map, I'm going to get the URL value associated with each of my Pokemons. I'm going to then open up a scanner to that URL. So this is a new endpoint on my Pokemon. So I still have the old data. I haven't not messing with that at all. I'm just saying, this name has a URL associated with it, which has more information about this dude. So I'm going to go ahead and take that string. I'm going to build a new URL object. I'm going to take that URL object. I'm going to build a new scanner object. I'm going to use that scanner object to read all the JSON data from that URL. Then I'm going to use my JSON parser to take that string data and turn it into map, a map object with stuff in it. All right. And that's what I have right here. Then I'm going to say, what kind of goodies did I get from that guy? I'm technically doing this for every single one of our things in there. So just so I don't have to have 4 zillion things printed to the screen, let's just do a quick little sneaky break here at the end of our first loop through. So I only get one set of information so I know what kinds of things we're dealing with here. All right, so this is a very temporary line here. Everybody make that makes sense to everybody? I'm in a for loop that's going to go through 1,350 times. And for each time I'm getting a JSON object that is really the same kind of object, same name value pairs. I just want to know what kinds of things are in there. So I'll just go through once. All right, what do we got here? We got abilities. Base experience. Cries? What's a cry? It's like a battle cry? What's a cries? I thought you were the Pokemon, Pokemon. So I'm gonna assume cries are like battle cries in like World of Warcraft, where it's like a perk to whatever. Forms, that's the thing with evolutions and stuff, right? Game indices, height, held items, ID, is default, location area, encounters, blah, blah, blah. Okay, so we were supposed to be able to get given a name, give me the ID, given the ID, give me the name, or whatever. I can put in either ID or name and it gives me whatever information about this dude. Is this supposed to give me a bunch of information or just go back and forth between name and ID? Doesn't really matter. We have all the data. Okay, so I give it ID, it gives me name and ID. I give it name, it gives me name and ID.
Yeah.
Okay, fine. Um, so actually this becomes kind of sort of easier. We didn't even have to go into the secondary thing, but probably what I would do here is well, here, let's just do it real quick since we only have 6 minutes left. Um, so what we're going to do, and I'm doing this all in main, which is probably not the way I would do it, but let's just do it anyways. All right, so I'm going to go ahead and ask the user. So we're going to put all this in like a while true loop. Oh, that was not even close to curly braces, was it? Let me get all this stuff. Oh, am I still in the try catch there? I am. I'm going to put that stuff inside of my while loop. All right. So forever, I'm gonna go in here. Actually, yeah, this is fine. So forever, I'm gonna go in here, and this is incredibly inefficient. Let's go with that. I'm gonna have a little scanner input is equal to new scanner system.in. So we'll read from the user, and then we'll say system dot out dot print, enter a, well, let's see, what do you want to enter? Do you want to enter in there? Actually, this will be okay. Do you want to enter \n one dot name \n two dot ID? Then we'll say string, actually, let's say int answer is equal to integer dot parse int of input dot next line. I think there's actually a next int that would allow us to not have to parse it, but we'll parse it anyways. All right, so I'm going to create a scanner. Let's us read in from the keyboard. I'll ask the user, do you want one name, two ID? If answer is equal to 1, then we're going to say string name is equal to, actually, let's say string input type is equal to, well, I'll just say string that. And then, so if it's 1, we'll say input type is equal to, we need the name from this guy. So we'll say input dot next line. And right before this, we'll do a system dot out dot print. Enter a name. We'll type it in. We'll have an else if this. Actually didn't even need to be that, but we'll do it anyways. We'll say enter an ID. Input type equals input dot next line. We'll read that in. So now we know whether or not we are searching for an ID or whether we're searching for a name. We'll go ahead and read in all of our stuff. So we have our map, we have our array list. We know what kinds of thing we are looking for in here. We'll go through, we'll ask the question. If I'm looking for a particular name, we're going to put in that name and we're going to compare it to the names that are in here. So we're going to say, if, what was it called? Answer. If answer is equivalent to 1, which means we're searching for names. Then what we can do is after we go through all of our map stuff, we can go ahead and, well, as we're going through here, we can ask, because we have what, name and URL? We can say, is the name associated with this guy? So if name what did I call it? I called it input type. If input type dot equals, ignore case. That way the user doesn't have to type in perfect names. And we want to compare this to the string version of m dot get name. If that's true, then I now have the guy that I need in order to find out his ID. All right. Otherwise, although it seems like we're going to need to get the IDs anyways if we need to give them both. Otherwise, we need to go in and do this stuff to pull in the information, or we can steal the ID from the end of the URL, which is probably what I would do. I would probably reverse it and then run. Actually, I would probably just separate it on slashes. The URL is blah, 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 slash this, slash that. I'd separate it on slashes and then get the last bucket. That's my ID. So regardless of what they asked for, boom, there you go. All right, well, we'll finish that up next time. Hopefully you saw how we can walk through our JSON and things like that. What I'm going to do next time is I'm going to pull these into objects. So we're going to build Pokemon objects out of this that have all the information associated with each Pokemon. And then we can actually do stuff with those Pokemon, like maybe merge sort them. All right, I will see everybody on Thursday. Going to chapel, front row, plenty of room. Everybody's invited.
So once I've sent my emails, how should I should I